let's begin today's exercise. If you can see, of course, where is the project, duplicate? Alright, cool. Alright, I've given you, if you haven't received, let me know, one of those A5 sheets. It tells you the questions in case you haven't been organizing and you lost all the questions, then there it is. I've uploaded that onto Schoology as well, so if you happen to lose it, it's there for you to look at. Now, today's session and last lesson was 1D and 1E. We're just working with worded problems because I taught you what linear equations were. I taught you simultaneous equations, what it really meant, finding the intersection between two lines, where they cross, and I proved to you the elimination method works because you're just balancing the equation. Okay? So what you're doing today is now you're applying that understanding. So you learned skill. What you need to know is how to apply. So you need to be able to read a question and then model that. And that's one of the hardest things about mathematics is like you can either learn the method, but when it comes to applications, why students find it difficult is because they don't know how to apply it. Why don't they know how to apply it? It's just generally because they don't understand it. Okay? So I'm going to do a couple of questions. So these are from 1D that you would have probably done. It was part of your questions. If you had troubles, I just tried to choose a few that I thought maybe the percentages get students, maybe they had troubles modeling it. So let's have a look at a couple of questions and I'll do one example for 1E and I'll set you guys on to the exercise. Okay? So have a look at question 5. This is from 1D. A wine merchant buys 50 cases of wine. Okay, so 50 cases of wine. He pays full price for half of them, but gets a 40% discount. And what I want you to, every time, any kind of application question, I want you to highlight, underline, or whatever it is, because the word, every sentence means something. Okay, so what it tells me already is, I've got 50 cases. So I don't care, I just know the total is 50 right now. That's the first step. Second thing is, it says full price for half of them. So if I know the total's 50, well, half of them has to be 25. So already in my head, how I'm answering the question is I'm sort of saying, all right, well, half of them is 25 of these cases. And, oh, is that where the past word's coming from? I gotcha. Okay, half of them is 25 and full price. So 25 of them is going to be paying full price. And then secondly, but gets a 40% discount on the remainder. But since I know half of them is 25, the remainder has to obviously be 25 cases. So that means the remainder 25 cases, I'm going to be paying not full price, but I'm paying 60% of the price because you got a 40% discount. So I know I'm paying 60% of the full price. Okay, so once I've got that sort of in my head, then it says the total of, it gives you a total of 2,260. So what it's really saying is your first batch of 25, whatever you're paying for, 60% is of your full price. And this is your full price, those two together should give you a total of 2,260. That's how I'm sort of seeing it. Because they said you paid full price for half, you paid 40% discount for the second half, and in total you spent 2,260. Your goal now is to model that. Okay? So, then they ask you, hey, find the full price. That's all they're really trying to find. So what I did was I said, all right, half the 50 cases was paid in full price, and notice I'm highlighting or bolding full price because that's clearly what I'm trying to find. The remaining 25 cases is 40% discount, which really means, and that's the key step here, that you know you're paying 60% of the full price. So, if I answer the question, if it's full price that I'm trying to find, I want to let it equal to X, because that's something I'm trying to find. I'm going to call it X. Okay, X marks the spot. So, X equals full price. I don't know what it is. But what I do know is they told me the total cost was 2,260. So how I modeled it was I said, all right, 25 of those cases times by the full price. Because if it was $10 each, you just say 10 times 25, you pay 250. Yeah, so I just wrote 25 times X, amount of full price. Then I also got the second batch, 25 groups of how much? Well, they said you're only paying, or there's a 40% discount, so you're only paying 60% of the full price. So that's what I'm going to write. 60% is 0.6. Of means times. Full price is X. How many of them do I have? I've got 25 of them. So that's what I wrote. I just wrote 0.6x times 25 equals 2,260. Now you've got a linear equation. that's what 1D was trying to do. See, if I simplify that, 0.6 times 25, which is 15. And so you got 25x plus 15x. In total, that gives you, what, 40x. And so you can find out x now, because it's just a linear equation, which is what 1D was about. 40 times x equals 2260, so divide both sides by 40. And you get your answer as 2,260 on 40, or $56.50. Okay, so what you can see is all I'm doing is I'm just modeling. What am I trying to find? What have they given me? Interpret the lines. Every line means something. Take a word out of it and try to model what you're trying to do. Okay, so first thing is, what are you trying to find? That's the very first step for any application questions for methods or spec. Find, make a goal. What are you trying to find? And then put the tools out. Okay? Next one. 3 girls are playing Scrabble. At the end of the game, there are 3 scores, so you've got 3. Okay, so the first thing I'm looking at is playing Scrabble. That doesn't seem to help me in any way, so I'm going to ignore that first line. It says at the end of the game, so okay, I finished the game, there are 3 scores. At up to 504, so in my head already I've got, okay, so there's 3 scores, so 3 numbers. Add together gives 504, so in my head I would have been saying x plus y plus z. Okay, I'm like, all right, if you add them all together, that should give you 504. That's the first thing that I'm sort of reading from the first line. The second line is Annie scored 10%. And what it seems like in this next line is that for every letter, there's a condition. And obviously, that's where I start modeling it, and I do it on separately. So this is how I did it. I said there are 3 scores, and I just went, okay, there are 3 girls, Annie, Belinda, and Cassie. So I went, let's call Belinda X. Let's call Cassie Y. Let's call Annie Z. All right, so that's the score. Belinda scored X amount, Cassie scored Y amount, and Annie scored Z amount. So what I'm going to do from there is I'm going to say, all right, well, X, Y, Z, if their scores add up to 504, this is what the first equation I've got. I've got X plus Y plus Z has to equal to 504. But remember, there are conditions. Annie scored 10% more than Belinda. 10% more than Belinda. So if Belinda had 10, then what you're going to do is you're going to do 10% of 10 and then add it on to 10. Technically, what you're really doing is you're finding 110%. Now, this is where a lot of students might have difficulty with percentages. That's why I want to do this one. Is because if I drew a picture, if this is Belinda's score, X, 10% more would just mean that you're adding on an extra 10%. So whatever Belinda is, this is 100%. That's 100% of Belinda. It's like you. You're 100% you. If I add another 10%, you take parts of you and add on an extra on top of you. So if Belinda is X, 10% more means that 100% of Belinda plus an extra 10%, which altogether is 110% of Belinda. Okay, because that's what I'm saying. Annie scored 10% more than Belinda. So whatever Belinda is, take 10% of her and add it on. So that makes it 110. Why do I want 110%? Because that makes it 1.1. Because 110 over 100 is equivalent to 1.1. So what I'm really saying there is Z must be equal to 1.1 times X. And that's a nice little condition there. Okay, that's all I'm doing. Instead of thinking of it as, oh, I got to find 10% of Belinda now, and then I got to then add that on to Belinda, that takes too much. If you actually just think about it, you're really just finding 110% of X, which is really 1.1 times X, and that should give you Z, which is Annie. Okay, that's from my first condition. Second one, you got Cassie scored 60% of the combined scores of the other 2. So Cassie is the score combined of the other 2. So who's the other 2? You got Belinda and Annie. So X plus Z, whatever the combined score is, hers is 60% of that. So times 60%, which is 0.6. And that should give you Cassie. So if I write all my conditions neatly now, so Z is 1.1. If I follow on with Cassie, Cassie is combined score 60%. Now here, sorry, I got this phlegm stuck in me. Z, we knew Z was 1.1x, So all I did was I said, since I know it's x plus y plus z, y is 0.6, so I just substituted y into here. But at the same time, I knew what z was, and I substituted that in here as well. Which is why I got x plus y, which is 0.6 times x plus z, which I already know z is 1.1x. Okay, so it's x plus z, and I've just replaced that z with a 1.1x. Why did I do that? Is because now I've only got x's to deal with. If I know what x is, I can find the rest. Okay, and that's why I did that. So that's z, that's x plus y plus z. So if I just rewrite underneath, x, y, z. There's a little z there. Okay, I've just replaced all of them. Why did I do that? Is because then it gives me only one letter to solve. And I got one letter to solve, it becomes a linear equation. Okay, and so from there, you can put them all together. You type in your calculator, 0.6 times x, and then 0.6 times 1.1. Add them all together, you get a collection of 3.36x equals 504. Divide 504 by 3.36, and voila, it gives you a nice answer of x equals 150. So if you know x equals 150 now, how do you find the rest? Well, this one says z equals to 150 times 1.1. Then you get z. How do you find y? Well, now that you know x is 150 and you found out z, sub it all in times 0.6 in your calculator, and you should get all the answers correctly, which is z equals 165 and y equals 189. So what was really hard, why I'm choosing these particular questions, because they've got percentages. And I find that students generally find percentages harder to model, fractions and whatnot. I think that's what gets students. That's why I'm doing these. Okay. All right. What's the next one? Another percentage one. All right. This one was significantly easier than the others, but I thought maybe the thinking behind it was a bit hard. So here we go. We got Kavindi has achieved an average mark of 88% on her first 4 maths tests. Okay, so this is the issue here, because in your mind right now, you're just thinking, I don't know what she got on her first 4. I just know that the average is 88%. You don't really need to know that 4, because when you're finding averages, the rule for the average is sum of all numbers divided by number of numbers. So right now, I just know the sum of 4 is something. So sum of 4 equals, let's call it x. So if you want to find the 5th number and you want to find the average, it's sum of all numbers, so add all the first 4, and on the 5th one. So if I called this x, it's really just x plus the 5th number, and divide by 5, that gives you the average. So if I model that, I just know that the first 4 maths tests, she scored x. So what I'm trying to say is she might have scored, I don't know, let's say 4 numbers, let's call it A, B, C, and D. Yeah? That's the sum of the first test. But you didn't really need to know that, because you just know that that gives you a total sum. And I'm going to call that x. Okay, so the sum of her test scores, the first 4 tests, gives you x. Why do I do that? Because I now know that the sum of all the numbers divided by the number of numbers, which I have 4, should give me the average, which they told me was 88%. Why do I want at x is because it's nice for the next question. The next part of the question says you now have a 5th number. So remember, 5th number would be a plus b plus c plus d plus e divided by 5 should equal to 90. But you didn't need to write a, b, c, d, because you knew a, b, c, d is x. So I can just say x plus e over 5 equals 90. And the nice thing is now you've got 2 types of equations. You can rearrange this, and that x equals to 88 times 4. If you know what x is, that technically tells you this. Then all you have to find is e. That's what the question's asking you to do. See what I'm doing there? So while it sounds hard, it wasn't hard. It sounded hard because you had so many unknowns. But if you think about what the average means, then if you collect them all together, it makes it easier. Okay, so this is what I did. I said, therefore, the average is x on 4, because the sum of the total of the first 4 scores, sum of all numbers divided by 4 equals 88. And then the next part is her 5th score, I called it y. So that means sum of x plus y divided by 5 should be 90. And if I rearrange x on 4, so I'll just write here in case you didn't pick up, x on 4 was equal to 88, therefore x equals to 88 times 4, which equals to 352. Okay, so that just tells me that this equals now 352 plus something divided by 5 should equal to 90. And that's what they're asking you. They said find that fifth score. What would the mark have to be for a fifth score in order to get 90? So now if you just put it all back together, you say, all right, well, therefore, multiply 5 on both sides. You see, I'm just multiplying 5 here. Balance the equation. 5 divided by 5 is 1. And then to get y by itself, minus 352 on both sides. So multiply that and then subtract 352, which is what I wrote in this line here. And you follow that on, whoops, not share. Y equals 98%. Or the answer should be 98, but then remember you're asking for a score. So it's 98%. She needs to score 98% on her fifth one to get an average of 90% overall. Okay? So you see how I'm doing it? I'm just reading the question, and it's about interpreting what is your goal. What is your goal? And the goal was fifth in this one. The other one was to find out x or find the common one, and then the first one was, I forgot what the first one was already actually. It was something. 1 cases, that's right. Full price. Any questions on that? That was 1D. I just picked a couple and tried to get you to see how modeling works. Yeah? All right, now 1E, no difference. I'm just doing one last example and then you can have a go with 1D or E again. All right. If 3 kilograms of jam and 2 kilograms of butter cost $29, 6 kilograms of jam and 3 kilograms of butter cost $54. Find the cost per kilogram of jam and butter. So all they did here, this is an elimination. This is a simultaneous equation of 2 equations because they gave you 2 conditions. If you think about it, what they told you is if I called jam J and I called butter B, I've got 3 kilos of jam, so I can just write 3 times J. Okay, so 3 kilograms of jam and 2 kilograms of butter, that will cost me $29. Where J tells you the cost of jam and B, butter, is the cost of butter per kilogram. Okay? And then they tell you the same thing again. They say 3 kilograms of butter and 6 kilograms of jam. So really 6 kilograms of jam and 3 kilograms of butter. That gives you a total of 54. What you can see is I'm modeling now a simultaneous equation where you use substitution method or elimination method. Okay? So really when you write it out, I want you to understand what you're really writing. Okay, yes, I know it's 3 times J, but why J? What is J representing? J right now represents the price of jam per kilogram. That's why it makes sense I said 3. Because if it's price per kilogram, let's say it's $5 per kilogram, I've got 3 kilograms. So 3 times 5 gives you 15. That's $15 in total. So $15 plus whatever it is for butter gives you a total cost of $29. Okay, so don't just write it because the way the questions are. Think about it. Why did you times? Because it makes a difference in year 12. When you're modeling it, there might be a difference between times, divide, add, subtract, or squaring. Okay, so you need to be able to understand what are you really doing? What are you writing? Don't write it just because you're writing it. Write it and question why it makes sense. In year 12, you're gonna have to label and meet the requirements on what a pronumeral represents. So what I wrote here, J is the price per kilogram. That's what you will be needing to do when you're year 11 and 12. Okay, because you got to define what you're doing. This is just a shorthand, but it has to mean something. Don't just write J because it's jam. Okay, why did I do 3 times jam? Why not 3 plus jam? All right. So once I've modeled it, I can now write it all out. Those are my 2 equations, and it's up to you which method you want. I prefer elimination method. It's up to you. Okay, you can practice either both. Either doesn't really matter. Okay. So what they did in your textbook is they did elimination method. They multiplied the first equation such that you can have an equivalent quantity. Times it by 2. So times this by 2, times this by 2, times this by 2. You get the 6x, you get the 6x. So equivalent quantity. Okay? You do that. Now they want you to subtract. You get 6x minus 6x. Nicely, it cancels out. And then 4y minus 3y gives you, negative 3y minus, that cancels out to be negative y. 54 minus 58, negative 4. Y equals 4. Okay? Substitute it back to find x, and voila, you got x and y. But remember, what do they represent? Jam and butter per kilogram. Okay? That's it. Exercise 1E. Simple. You got your sheet, and I'm going to upload this video in case you need it. Okay.